Good day guys, let's see another problem on the second order differential equations. Again, it is one with an exponential on the right hand side. So our procedure starts with getting the general solution. We will calculate our complementary function first. So the procedure has not changed. So I will use that to create a quadratic. Second derivative will be called r squared. First derivative will be r. My y will be 1, so that 6 times 1 is a 6. Don't make a mistake to call it 61, please. Then the right hand side, it's always a 0. So that's my quadratic. So step 2, I have to solve this quadratic. This one for me looks simple because it looks factorizable. I think this is r plus 2 multiplying r plus 3. If we use factorization, you can see it's r squared, 5, 3 plus 2 is 5, 6, yeah? So it shows that our r1 is negative 2 and r2 is negative 3. So again, r1 is different from r2. So that is it. So as an N6 student, you will then go to page 7 of your formula sheet to look for this to help you write your YC. So it shows to us that our YC is a e to the power r1, our r1 is negative 2 times x plus b e to the power r2, r2 is negative 3x. So that's all about your YC and your complementary function. So now it's time to go to our YP. So our YP will always depend on the kind of function we've got on the right hand side of your original differential equation. So now there's one thing I want us to talk a little bit about. So I keep saying when you're choosing your YP for exponential, you have to search for this exponential in your YC and check whether do you see it there. If you look at it, you see that e to the power negative 2x already appears in YC. You see e to the power negative 2x. So that therefore means our YP this time will be cx e to the power negative 2x. So that will be now your choice for YP. So if, for example, this was a positive, then you see that when I search e to the power negative 2x, you see it won't appear here. And once it doesn't appear, the x will not be part of it. I'll just get c e to the power 2x. But immediately I look for this e to the power negative 2x. I see it appearing exactly in YC. Then my choice for YP becomes like that. So guys, these are the things that we need to know when it comes to the exponential. We must know whether is our YP going to be cx times the exponential or will it just be c times the exponential. And you can see when writing the YP, I don't care about what constant is there. So from here, we can now go to the normal procedure. We differentiate our YP 2 times. So for the first time, I'm differentiating. And this is another key point that students should take note of. You must realize that what is written here is a product. There is a linear function and there is an exponential. So when I'm differentiating, I'm expected to use the product rule, where I'll be using my u v prime plus v u prime. And again, you must remember that with differentiation, constants are not supposed to be differentiated. So I will be looking at this problem like this, so that I don't stress up my constant. I simply do my product rule in the variable only. There's no need carrying the c up and down. So I will take my u v prime. V prime means I differentiate e. It will give me negative 2. Then my u is x. So my u v prime is negative 2x e to the power negative 2x plus my v u prime. U prime means I differentiate x. It will give me 1 times v, which is e to the power negative 2x. So you can see that our first derivative, if I open up my bracket now, you see c is a constant, there was no need carrying it up and down. I've differentiated the important part, which is the variable, then I'll just multiply by c to get negative 2cx e to the power negative 2x. Then c also multiplies there to get c e to the power negative as for now, that's just the first derivative. I'll just transfer that first derivative up here so that it can help us with the calculation of the second derivative. E to the power negative 2x plus c e to the power negative 2x. So I can now do the second derivative. And again, if you can still remember what I explained to you with differentiation as well as integration, you don't usually bother yourself with the constant. If I need the second derivative, I must redifferentiate this. And again, looking at this, that variable, the important part, which is a product, is there, which is your u and v. So you see, I've kept away my negative 2c. That's a constant, there's no need to carry it up and down. So if I'm looking for the second derivative, it means I'll get negative 2c. Then I multiply it by the derivative of this, which is product rule, which a smart student will know that we did it already in the first derivative. You see, the solution is there. So I just copy and paste it, and it saves me a lot of time. So I'll get negative 2x e to the power negative 2x plus e to the power negative 2x. So that's my derivative of this one using the product rule. Then I can differentiate this one, which is separate from that, which will create a negative 2c. You see here, there's no longer a product because you can't call c part of the product. This is a constant. There is no x here. So if I differentiate this, I'm only differentiating e. So I'll get negative 2c e to the power negative 2x. So I can now open up my bracket to see what is my second derivative. These two become a positive 4cx e to the power negative 2x. Then this one multiplied it to give me negative 2c e to the power negative 2x. This one will be negative 2c e to the power negative 2x. These two are like terms. Then you see that the second derivative of yb is reducing to 4cx e to the power negative 2x. Then minus 4c e to the power negative 2x. So when it comes to exponential data of this nature, we will need product rule. That's how long it takes us. Then we can now continue our job. We are going to use the second derivative to replace the second derivative that side. As before, the first derivative will replace the first derivative in the original equation. So we are going on in the place of d squared y or dx squared and putting the second derivative of yp, which is 4cx e to the power negative 2x minus 4c e to the power negative 2x. Then it's going to be followed by plus 5 into the first derivative of yp, which is negative 2c e to the power 2cx e to the power negative 2x plus c e to the power negative 2x, then plus 6y, or y will be yp, so that will be 6cx e to the power negative 2x. Let's go to the right hand side, which is 3 e to the power negative 2x. So this is the step where if you have not made a mistake up to so far, you will pick it out from the fact that every term with cx will now fall off. If you can open that bracket, you'll see that everything that has cx will fall off. There is 4cx here, then there is negative 10cx here, there is 6cx. So you see that 6cx plus 4cx is 10cx, then this 5 multiplies there. You see negative 10cx. So you see the terms in 10 in cx are falling off to show that we didn't make a mistake. So we only concentrate on the terms with c. So if I'm concentrating there, I will see myself with negative 4c e to the power negative 2x. Then 5 multiplies there is plus 5c e to the power negative 2x should be equal to 3 e to the power negative 2x. So as I explained, 6cx e to the power negative 2x plus 4cx gives you 10, and you see that is negative 10. 5 times negative 2 is negative 10. So if you want to be sure that you've not made a mistake, every time in cx will fall off, then you concentrate on the rest. So 5c minus 4c will give us c e to the power negative 2x is equal to 3 e to the power negative 2x. You can see that e to the power negative 2x will take care of one another. Then you get your c as 5. Once you've got c, it means you now know yp. So therefore, our yp is equal to 3x e to the power negative 2x. And once I know yp, I can now write down my general solution as yc plus yp. And what does that mean? Yc, we got it up there as a e to the power negative 2x plus b e to the power negative 3x. Then this one is 3x e to the power negative 2x. So this is our general solution as before. So you can see up to so far, we did not touch the conditions that were given from the beginning. So if we go back to the conditions to help us get A and B, so as to arrive at a particular solution, the first condition says y is equal to 3 when x is equal to 0. So what does that mean? If I go through the whole general solution, I will replace y by 3, I will replace x by 0, e to the power 0 is 1, e to the power 0 is also 1, and left with b. Don't forget here, 0 means this is 0, so that is my equation number 1. Then I check the second condition, which says dy by dx is equal to 0 when x is 0. So dy by dx we always get from differentiating the general solution. So if you differentiate the general solution, you get dy dx is equal to, differentiate this first term, you will get negative 2a e to the power negative 2x. The second term, you get negative 3b e to the power negative 3x. Then the last term, please do not forget again, this item is a product. So we need product rule where we've got our u and our v. And if you are smart enough, you will realize that this same product rule, you did it under yp. When we were doing yp, we saw it there. We gave that answer. Then we were doing the second derivative. We saw it there. We copied and pasted. So it's the same thing. We're just copying to paste here. So you don't need to stress yourself repeating things that you've done. So the derivative of x e to the power negative 2x will be negative 2x e to the power negative 2x plus e to the power negative 2x if I apply the product rule. So I can now substitute and replace dy dx by 0, and I replace every x by 0, e to the power 0 is 1, so this is negative 2a, this one will be negative 3b, and when I come here, this first term will be 0, because of x here, this will be 1, so 1 times 3 will be a 3, so 3 will move that side to be 0, so that I get negative 3 is equal to negative 2a minus 3b. And if I want this equation to be friendly with that one, I can divide all through by negative 3. Yeah, I can do that. If I divide by negative 3, it means negative 3 divided by itself will be 1. Then this will be 2 over 3a plus b. So I prepare it like that so that I can easily eliminate b. So to solve for a and b, I now use subtraction. So we'll do that this side. I can take equation 1 minus 2. If you look at equation 1, on the left is a 3, on the right is a 1. So 3 minus 1 is a 2. We'll go that side, you'll see that b minus b will be eliminated. Then I'll get a minus 2/3. That should give me negative 1/3 a. So now if I calculate a, this will be negative 6 for a. So from there, I can now use equation 1 to solve for b. Equation 1 is 3 is equal to a plus b. But we all know that a equals negative 6 plus b. So negative 6 is a friend to 3. That tells us that b is equal to 9. So therefore, to get a particular solution, we will copy the general solution, replacing a by negative 6, e to the power negative 2x, b by positive 9, e to the power negative 3x, plus 3x e to the power particular solution. Thank you very much. I guess with differential equations, we are done.